Welcome to What If Tech. Today we're going to talk about mathematical set theory. Today is also the beginning of the new ETH Zuerich entrance exam series on this channel. There we will provide you with resources and guidance through the study process for the entrance exam of this prestigious university. For this process we will use this OneNote I previously created. There you can see all the subjects that will be asked from you on the entrance exam. The link to this OneNote will be in the community Discord. You can join the Discord via the link in the description. If you're on the Discord, you can go to ETH OneNote and click on this link. If there are any errors in the OneNote, please let us know in this channel and we will try to fix them. So we'll have a uniform OneNote that everyone can study from. Because this is the first video of this series, I'm shortly going to go over the structure of this video. We're going to start off with the theory part of the topic. What do you need to know about the topic? After that, we're going to go over some general examples, mostly provided from the Austrian Matura, equivalent to the A-levels in England. And after that, we will go over some ETH Zuerich examples, but in this video, set theory is not that relevant for the examples that will be on the entrance exam. It's most likely in the task description mentioned like a set of values that is allowed in your solution. That will be the structure of the videos in this series. A short disclaimer: if you like this type of video and you want to support our channel, consider liking this video and subscribing to our channel. It would help a lot. You can also join our newly created Discord, where we'll share updates on our recent uploads and tech news. Now back to the video. Now let's start off with the topic of this video: set theory. What is the textbook definition of a set? A set is a collection of distinct objects which are called elements. Elements can be numbers, symbols, points in space, etc. Sets are written with curly brackets and named with a capital letter. So the set A has the elements 1 through 4. In visually described, set A has the elements 1 through 4 and 5 is not in the set. There are generally defined sets in mathematics. You should know them by heart. Natural numbers include 1 through positive infinity. 0 is not in the set of natural numbers. Whole numbers include the natural numbers plus the 0. So the set previously is in the set that's afterwards. The integers include all whole numbers and whole negative numbers. There are no fractions and decimal numbers allowed in this set. Rational numbers include fractions. These are numbers that can be described as a fraction of two integers, a and b. B is not allowed to be 0 because you can't divide through 0. Irrational numbers are all the numbers that cannot be expressed as a ratio of two integers. And the real numbers combine rational and irrational numbers. As you can see in this graphic, this implies natural numbers 1 through positive infinity, whole includes the 0, integers the negative whole numbers, rational includes fractions 1/3, 4, 5, periodic 6. Irrational cannot be described as a fraction of two numbers, of two integers. And real numbers combines irrational and rational numbers. Elements in a set are described with this symbol. It looks like an estranged E. 2 is an element of A. If it's crossed out, it's not an element. So 5 is not an element of A. As you can see here, 2 is an element, 5 is not. Equivalents of sets, sets with the same elements, it doesn't matter the order, are called equal. So the set 1, 2 and 3 is equal to the set B 3, 2, 1. The cardinality of sets, the straight lines around the set definition. How many elements are in set A? Example, A has the elements 1, 2, 3, and the cardinality would be 3 because it has 3 elements. To describe a set, we can use 3 forms. The semantic form, it's a plain text description which does not follow any mathematical guidelines. So A, set of the first 3 even natural numbers. The set includes 2, 4, and 6. Roster form, the elements are enclosed with curly brackets. And the last form is the set builder form. The difference to the semantic form is that it follows mathematical guidelines and it describes the rules that the set must follow. So x is an element of the natural numbers and x is smaller or equal to 10 and x is even. The visualization of sets is done via the Venn diagram. It describes which elements are in a set and the relations between sets. There are many different types of relations and we're going to go over them now. So the bridge-like symbol is a logical AND connection. Elements are in the set A and in the set B. The symbol is called intersection. Elements belong to A and B. In the Venn diagram, it's the part that is red here. These elements belong to both sets. The big U symbol is called union. Element is in A or in the set B. It belongs to A or B or both, and it's a logical OR connection. So everything in the two sets is red and in this set. This symbol is called a complementary set. Every element that is not in the symbol A, in set A, is in the set that's the result set of this equation. The slash is backslash is the difference. So A difference to B, elements which belong to A but not in B. These elements belong to A, these to B, and because these intersect, these are not in the result set, because they're also in B. The last two topics of the theory part of this video are important types of sets, other than the mathematical sets we covered previously, and intervals. Important types of sets are the singleton set. The set only has one element, so the element of A is 4, or in set builder form x is a natural number between 2 and 4. Infinite sets, the set B has unlimited elements, x is multiples of 2. The set C is an empty or a null set, so it doesn't have any elements. And the most important set for the entrance exam or any exam you will take in mathematics is the solution set. In this set you write the solution of your calculations. Other forms of sets are a subset and a strict subset. So a subset is a set that has the exact same elements of another set. So the set 1 to 3 is a subset of the set B 1 to 3, but it's not a strict subset. A strict subset would be the set A 1 and 2, and B has the elements 1, 2, and 3. So there's an element in B which is not in A. So A is a strict subset of B. A is not equal to B. If it's only a subset, so the elements of both sets are equal, it's a normal subset or superset if it's from the other direction. Intervals. Intervals can be described with the number line or the interval notion. In the interval notion, the interval is enclosed in square brackets or round brackets. Square brackets mean the interval includes its borders. It's also known as enclosed interval. So 0 and 20 is included in the interval. If the borders are round, the borders are not included, and the interval stops at 1 and 19. It's known as an open interval. The second visualization of an interval is the number line. A filled-in circle means it includes its border value, and an empty circle means it doesn't include its border value. The last important part is using infinity in an interval notation. That means if you have a function and you want to describe some parts of it, you will need infinity in your interval, and the infinity part has to have an open bracket, so an open interval on this side. The other side can be closed or open, as you can see here. Now we're going to go over some exercises for the theory we just covered. If you want to try the exercises yourself, you can pause the video, join our Discord, click on the link in the channel, and you can see these exercises. Also, there is some additional information on every page that will not be covered in the videos. So if you want to see the additional information, also join the Discord. Because set theory is not really a standalone topic on the entrance exam, I included some general examples from the Austrian Matura. On other topics we can include whole ETH Zuerich examples, but because we just started the series and we didn't cover other topics, I didn't want to include multiple topics in one video. On a later time we can come back to set theory and cover entire tasks of the entrance exam. So here the task description is in German, but because this is an English video, I translated it here. You can read it, you can pause the video and read the task description. Our task is enter the missing numbers in the 5 designated boxes in the Venn diagram. Here we can see the Venn diagram and the sets we have to intersect and the entire G set. So G is the set that covers all federal states, F the federal states with photo evidence, D with DNA evidence, and L with permanent settlement. So we're going to go back to the table and we're going to remember the rows which have the set D, which is DNA evidence, and F, photo evidence, set to yes or ja in German. So Kärnten has yes 1, 2, 3 and 4. Because these have all 3 set to yes, these are in another set. The sum of these numbers has to be the amount of rows in the table. It can't be more or less because everything has to be in a set. So we just covered 4 are intersecting. They have DNA evidence and photo evidence. So here a 4. I have the solution under this, so I will scroll down later on so you can solve them by yourself in here. So next is the intersection between D and L. DNA evidence and permanent settlement. DNA evidence, permanent settlement, 1 and 1. So here a 1. F and L, photo evidence and permanent settlement. That means photo evidence, permanent settlement means 0. Yeah, 0. And all 3 to yes, 1, 2, 2. And nothing to yes, 1 and 2. Now we're going to check 0, 2, 1, 4 and 2. We did right. Now we're going to go over task 2 and 3. Task 2, write the set that is shaded gray in the Venn diagram above using set notation. As you can see here, the gray area is this area, which means we need to union join the set F to L, so we get the big set here, and we have to subtract the D set from this union join. So we write in brackets F union joined to L difference to D. Then we have the part here, but we're missing the gray part above, so we need to use D and do the set difference to the union join of F and L, which means we take this big set, which is a union join, and we subtract D from this set, which gets us the gray area without the white area here. In the solution, you can see how it's written. The union join of F and L, which is the gray area, plus the white area. Set difference with D, which subtracts the white area from the gray area, and we union join D set difference or minus the union join of F and L, which subtracts us again the white area and gets us the above gray area. The third task is list all federal states that belong to the set, see point 3 in picture, G, and the set difference of F union joined to L union joined to D. That means we need federal states that don't have photo evidence, DNA evidence, or permanent settlement, which means that every column has to be 9 or no in English, which is the Burgenland and Wien. So the solution of task 3 is Burgenland and Wien. As you can see here, we are right. We're almost done with the exercises and the video. We're going to do an easy exercise to finish off. It's good for the understanding of the topic though. So the English task description, task 1, mark W intersection M in the Venn diagram above. If you want to try it yourself, pause the video. The intersection is the elements here. These elements are interlocked with W and M and are in both sets. Task 2, describe the meaning of the set we just colored in. As you can see, W is the set of disections that are grazed by sheep, M is the set of disections that are mowed. Because it's an intersection, the set that we just colored in are disections that are grazed by sheep and are mowed. Now, on to task 3, express the set of disections that are not maintained at all in set notation. We have D, set of all disections, and W and M. 19 disections are not maintained at all, which means we need the set difference of D and the union join of W and M. Those are all the elements which are not grazed by sheep or mowed, so not in these sections or sets, and are not maintained at all. So the 19 are this set. In set notation, D backslash W and the U for union join and M. The last task of this exercise is task 4. Calculate what percentage of the disections are not maintained at all, which means we have the 19 disections that are not maintained. We have to calculate how many disections are there, which is all the disections, a sum of all the disections and 19 divide through the sum times 100 because it's percent, and that is 14.84%, or if you round the result, 15%. Now we go over the usage of the set theory in ETH Zurich examples I found. For example, in a task in the mathematics part 1 in 2024, the task was bestimmen Sie alle Lösungen. X is an element of 0 and 2 pi. This is an interval, and 2 pi is not included in the interval. So if your result was x equals 2 pi, you wrote it in your answer, it would be wrong. Another example I found was gegeben ist die Funktion, and n is an element of the natural numbers. If you don't know what natural numbers were, you would be screwed, but now you know, and you're one step more prepared for the entrance exam. If you enjoyed this video, consider liking, subscribing, and leaving a comment down below. Don't forget to check out our new Discord. If you have any feedback, hit me up on our Discord.